I'll begin. Hello and welcome to everyone to the Nottingham Festival of Science and Curiosity 2021. Thank you for coming, whether you've attended before or whether it's your very first FOSAC event. For further information and details, please visit our website, notfosac.co.uk. Today we'll be joined by psychology students Ifigenia and Hannah, who will bring to you Daily Brain Tricks Live, their second event. Today they'll be exploring the trickery of illusions and how our brain can easily fall to see things in a certain way. I'm Isabella Oakley. I'll be in the background as your host for today and monitoring chats and questions that come through. I'd like to remind people of the code of conduct. We will be making our own recording of the event, so we'd like to ask participants not to record, not to take screenshots or photographs of the event. It's great to have an audience participation, so we urge you to contribute in the chat and ask any questions you have in the Q&A section. And I'll hand over to Hannah and Ifigenia. Take it away.
Thanks, Izzy. So I'm Hannah. I am a psychology graduate from the University of Nottingham, and I'm currently studying my master's in mental health.
And I'm Ifigenia, and I'm also a psychology graduate from the University of Nottingham, and I'm currently doing my master's in occupational psychology. And today we'll be talking to you about illusions. So let's see. People rely on their senses, including sight and hearing, to make sense of the world. So the eyes and ears send information to the brain through neurons. So we can think of neurons as the messengers that share the information that our eyes and ears get from the world. So here we have some cute pictures of some neurons. This is what one neuron would look like. And then these are two neurons talking to each other, transferring the messages from one another, from the ears to the brain. And then our brain has hundreds of billions of these neurons transferring messages all the time. And they are the reason that we can feel, think, and act because of the messages that they're transferring the whole time. So then why do we experience illusions and why do we have to study them? So sometimes these neurons send the wrong messages to one another, and so our brain is playing tricks on us. Therefore, we perceive things differently to what they actually are, and so we experience illusions. If the misinterpreted information comes from our eyes, then we have a visual illusion. And if that information is coming from our ears, then that's an auditory illusion. So studying illusions is important because we can see through studying illusions how the ears and the eyes can communicate with the brain and what happens when that goes wrong. And also it's really fun to study illusions, as we will see.
So you may have seen this illusion before. It's a very old one. So we just had a quick poll to see who sees what. So hopefully Rick would be able to put the poll up now. So we're asking, do you see a young lady? Do you see an old lady? Or do you see both? Just wait a couple of seconds for you to vote. What do we have? We have half seeing both. 43% of you saw the young lady, but not many of you only saw the old lady. So if you can't see both, the young lady is facing away and the old lady is facing forwards. So the chin part of the young lady is the nose of the old lady. But most people are seeing both. It is actually dependent on a bunch of things, what we see at one time. So people that are younger often see the young lady, and people that are older often see the old lady. And this is because we are more used to seeing faces that look more like us. So if we're younger, we're more likely to see the young lady because we are used to seeing faces that look younger. So there's another one that is similar to this, which you might have also seen before, which is the rabbit and the duck. So the rabbit with his ears, which is the duck's beak. So this is actually different in different times of the year. So at Easter, people are more likely to see the rabbit first. And then at a random time in October, people are more likely to see the duck first. So it can depend on what we are thinking about at the time, what we see in these illusions.
So now we've got a different illusion for you. Can you see the white triangle? You can just pop it in the chat if you can see the white triangle.
Yeah, we've got a couple of people saying yes, they can see it.
Well, that's great, but actually there is no white triangle. It's just some shapes placed strategically here, so we can see like this three Pac-Man sort of shapes over here, and then just these random lines. There is no white triangle. It's just our brain filling in the gaps.
What does anybody see in this image? So can you see what this image is? May have had a little sneak preview. Do we see a dog in the snow? Yes, got a couple of people seeing that. So again, this is similar to the other one with the white triangle. If you can't see it, we'll put a little outline. There he is. Actually, this picture is just lots of black splodges. There is no line work to make up the image, but we can see it anyway, again, because our brain fills in the gaps for what we can see.
Now let's have a look at the next illusion. What would this middle shape be? So this again depends. Oh, the slides are changing by themselves. I'm not clicking on them, so that's interesting. But oh well. So this middle shape, let's have a look at it. If you look at it in this context, then you can clearly see that it's a B because the surrounding context is also letters. But if you look at it like this, it's a 13 because the surrounding context is numbers. So it can be both, and it just depends on which way you're looking at it. So this shows us the importance of the background and the context when we're interpreting messages that our neurons are sending about. So here we've got another illusion and another poll. We want you to tell us which circle you think is bigger. Is it the left one or is it the right one? So let's have a look. So most of you have said that the right one is bigger, but actually, are you ready for this? They're the same. They are the same. Exactly the same. So it just depends on the background once again. Here we have circles that are bigger than this one, which make it look smaller. But over here we have circles, the surrounding circles are smaller, making look the middle circle bigger than the other one, when in reality, they're the same.
So we do have another one similar to this. So the monster that is on the right-hand side at the back, this looks bigger. Our brain is seeing this as a bigger monster than the monsters at the front. The bigger one is chasing the smaller one. And this is because we have all of those lines that makes it look like a 3D image. If something is further away, it should be smaller than it is because it's further away from us. But when you take the background away, it's very easy to see then that they are the same. So these lines are the height of the monsters and they are exactly the same. So it is just the background that is tricking us to think that it's bigger because it should be further away. So we have a similar idea with the 3D tables. So the one on the left looks like a much longer table than the one on the right, which is nearer to being a square shape. but actually the tops of the tables are the exact same shape, and it doesn't look like it. You probably don't believe us. So we'll see what it looks like when we spin it round. Slide it over, and it is the exact same shape.
So now we've got something really interesting based on the same idea again. So here we have the Ames window. We can see this side as being closer to us because it's bigger. This is a flat shape though, and this slide is further away from us, so it looks smaller. So let's see what happens when we take this shape and we spin it around.
Now here's the spinning motor. It's simply a piece of cotton thread tied to this corner and tied to the other corner, and I've wound it around in my fingers so that when I let it go in a moment, it'll unwind, the thread will unwind, and you'll see the thing spinning. There we are. I'll hold it the same level as your eyes and we'll let it go. Now you know that it's turning around in circles. In fact, if you look at it from above, you can see that it's turning around in a circle. But now your brain is doing something strange. It's telling you that it's not going around in a circle, but it's oscillating. In other words, it's turning part way, stopping, and then going back the other way. Now that's a strange effect, isn't it? But if you think that's strange, wait till I add something through the middle. What am I going to add? Well, I'm going to add a ballpoint pen. And to do that, I've placed a little piece of double-sided sticky tape on the ballpoint pen. You can use ordinary sticky tape if you like. I'll place it right through the centre of the window and press it in place like that. Now this time, by fixing on the pen, you'll be able to see that the pen is going around in a circle and not going backwards and forwards. But what's your brain going to tell you about the window? Will your brain allow you to see the window going around in a circle with the pen? Or are you going to see something really strange? Well, have a look at that. That's unbelievable, isn't it? You can see the pen going around in a circle, but your brain is telling you that the window is going part way around and turning and going the other way. And yet in order to do that, the two things have to pass through one another, the pen and the window. You know it's not possible. You know it can't happen. And yet as you look at it, you see them going through one another every time they go around. An amazing illusion, the Ames window.
That's truly mind-blowing. I mean, I don't know how many times I watched this before this presentation, but it still works.
So the next set of illusions that we're going to show you is some colour ones. So the grey bar in the middle looks like it is paler on the left and darker on the right. But when you move that bar down and you remove the background, you can see that it's actually the same colour the whole way. But we are just interpreting it as lighter because it's against something that's darker, and then darker because it's against something that is lighter.
So now we've got a similar one. We clearly see that the square behind A and the square behind B are different, but actually the two squares have the same color. And if you don't believe us, we can show you. So this is interesting because you can see how the square just changes.
It just looks like you're changing the colour of the square though.
Well, let's have another look. How about now? Exactly the same color. So it's just again, it's showing that the background really affects the way that we see color and the way we perceive it. So this happens because the color, the light, and the patterns in the environment focuses on our eyes and brain, and our brain interprets the message, and the neurons deliver the message based on what we expect to see based on the background. And as we've said, all these illusions still work even if you know what happens behind them. You cannot unsee the illusion. It's just how your brain works.
So you might have heard of this dress that went around the internet a few years ago, and this is the same principle. So some people see a white and gold dress, and that is if your brain is thinking that this dress is in shadow and there's a light behind it, it is thinking this is what that dress would look like in those lighting conditions, if it was white and gold. So that's what you see. And people that see the blue and black dress, if you think that the dress is lit from the front with a bright flash, then your brain is thinking, okay, well, that's what a blue and black dress would look like in those lighting conditions. So people that see white and gold, I only see white and gold. Ifigenia only sees blue and black. We both think each other is crazy, but there are some people that can switch between both of them. And it's actually not quite understood why some people are seeing one way and some people are seeing the other, but your brain is tricking you either way. And the real dress was blue and black.
So now let's have a look at another color illusion. Please have a look at the black dot in the middle of this picture. And have a look at it. Keep looking at it for 30 seconds. So now you should be able to see a perfectly colored castle. However, by now the colors should have faded and you can see that actually it's a grayscale picture. So you can see this was the picture you were looking at before, and this is the grayscale picture. So what happens?
So when we have looking at colors, we have different neurons in our eyes that help us see all of those different colors. So we have specific neurons for each color that we could possibly see. And the colors that we are seeing when the picture is inverted, the one that was looking like yellow and blue, those neurons are continually firing as we're staring at it. And because we're staring at it for a very long time, they get overworked, they get a little bit tired, so they're not as sensitive. That image goes away, and very quickly we see the opposite color. And that's because the colors of the opposite side of the color wheel, so if you saw yellow before, you would see blue. Those neurons, they're not tired because they haven't been working the whole time. So they fire a lot stronger than the ones that were working before. So we momentarily see the inverted after image in color. And then once you've had a couple of seconds, it probably did fade. And that is, they've picked themselves up after being really tired and they've started all working again.
So now the next slide has a moving spiral. So we would like to ask any people who might be sensitive to this to look away for a while, and we'll let you know when it's safe to look back. So for the rest of you, just spend 30 seconds looking at this moving spiral. And after 30 seconds, look at a flat surface. This can be a wall, it can be a desk, and tell us in the chat what you can see. What do you see, Hannah?
Wow. Every time. So we have a couple of people in the chat. So when looking away, the object begins to move in the spiral motion. After a little while, it should return back to normal. The table is moving, yes. It is the same principle as the color ones. So this is, we have some neurons. We have neurons that detect motion in different directions, and the ones that were used to see those spirals moving in one direction get really tired. So when we look away, the ones that are supposed to be detecting the ones in the other direction, they're a lot stronger. So you can see movement in probably the opposite direction to how the spiral was going. It might just look like kind of swirls, kaleidoscopes, but that is some neurons are really tired and they're not working as well, and some neurons are therefore really, really strong. So we're seeing movement when there isn't, and that is called the motion after effect.
So we've looked at loads of visual illusions. Now let's have a look at an auditory illusion. So these are the ones that the neurons transfer the wrong information from our ears to our brain.
Concentrate first on the right of the screen. Now to the left of the screen. The illusion occurs because what you are seeing clashes with what you are hearing.
In the illusion, what we see...
So I think that was a bit short, so let's have a look at it again.
Concentrate first on the right of the screen. Now to the left of the screen. The illusion occurs because what you are seeing clashes with what you are hearing.
In the illusion...
So what happens is
the illusion occurs.
the sound is the same. However, when looking at the picture, this person is saying ba, and then the other person is saying ba. The sound that you're hearing is the same, but because you're looking at different mouth movements, your brain can't really handle the contrasting information. It can't not clash. Your brain has to interpret it in a way that makes sense. So despite the fact that you're hearing the same sound, what your brain tells you that you're actually hearing matches the mouth movement that you see. So it's an auditory illusion then.
If you have ever misheard lyrics in a song, then this is pretty much the same as what is going on. So your brain is thinking that you know the lyrics and you're thinking that they are saying a certain sentence or a certain word, and you're hearing that sound and your brain is interpreting that sound to what you think that is. If you think it's something different, then you'll hear the exact same sound saying a different word.
Exactly.
Because what you...
So that was all from us. We talked about visual and auditory illusions. And yeah, we have a question now. Let's have a look. So is there any difference between looking at things on the screen and looking in real life? That's a really good question, actually. And a few of those illusions that are very recent that I was tempted to add in this presentation are talking about exactly that. So it is said that looking from screens and looking from different screens either. So looking at your PC and looking at your phone, that's going to change the way that you perceive things because the light is different. So yes, there is a difference between looking from screen and in real life indeed.
The 3D images in real life won't necessarily work because it is real life, so they would be further away. If you've ever seen the places that you can go to that have visual illusions, they will do the same sort of thing with making it look like it is 2D, but it's actually 3D. So it can work like that. But in normal life, the reason why we have these illusions when we're looking at a 2D screen is because of our experience in real life looking at 3D objects and what we've learned from that.
Yeah.
So in answer to your question, it depends.
Are there any other questions?
Yeah.
I think Rick might have asked whether it's possible to see, was it blue and gold on the dress? I don't believe anybody has seen that. I think essentially what we are seeing depends on what our brain thinks a picture would look like given those lighting conditions. In the particular image, it's very difficult to see what the lighting conditions are. Is it a flash from the front or is it backlit? And therefore our brain interprets it accordingly. So the darker colours will go together and the paler colours will go together. I don't believe anyone has seen a mixture of both.
Great, okay. Well, we'll keep an eye out for any more questions being sent in. But it's quite interesting, fascinating, because even though knowing some of those illusions, I still fall for them time and time again. And that oscillating one, it gets me every time. That's a crazy one. So thank you all for listening and participating today. A huge thank you to Ifigenia and Hannah. Another brilliant Daily Brain Tricks episode. Keep your eye out for the next episode and the final one on Monday, as you can see on your screen. they'll be back on the 15th at 12:30, same place, same time. Keep an eye out for other events and activities on our website, and we'll look forward to seeing you again. Thank you ever so much, and we'll see you soon. Bye.